Hello class, so today I'm going to talk a little bit about what's called a piecewise function. Piecewise functions have different subgraphs, if you will, and one specific subgraph of a piecewise we're going to talk about today is step functions. So a piecewise function is, imagine taking two different functions and bringing them together. So say you have a linear function. So we just draw a linear line, potentially, and then maybe at some point it changes from linear to maybe an exponential model or a quadratic model, right? So all of a sudden we've changed what type of function, or we've pieced two functions together to make a new graph. Because we've pieced these two different functions together, this is in part where the term piecewise function comes from. Now, as I said, a special type of piecewise function is called a step function. So let's talk about a step function and what is it and how does it work. So step. So I know yesterday you guys were exploring some interest rate growth, and you asked to graph that. Now there's two different graphs you asked to graph. One graph was dealing with standard interest rate, and the other was dealing with more of an exponential interest rate. And what we could see is, so if we have our years, well, year 1, year 2, year 3, year 4, year 5, and let's say we have $100, and from here we're going up some amount. And let's say we're getting 100% interest rate in this example, and that's paid on the first day of the first day of the year, right? So let's say the interest is paid on the first day of the year. So it's standard, right? So we make a deposit, and we make a deposit, so we have a circle here of our amount, and it's going to stay that $100 for that whole year. And once we get to year 1, we're going to get that interest. So that interest will make that jump up to $200. And so we'll have the amount of $200, and we'll stay at that amount for the whole year. And so we're staying at that amount for that whole year. And so we have this flat line, because we're not adding to, we're not taking away, it's staying a consistent number for the whole year. And at the end of year 2, we get 100% interest. So if we have $200, and we'd now jump up to $400. So we'd jump up to $400, and we'd stay at $400 for the whole year. So this is usually compounding. And then as soon as we hit year 3, once again we get that 100% interest. So we'd go from $400 to like $800, and we'd stay at $800 for 1 year. And so we see that we jump faster and faster within this case. And so we might, if we would come up with an equation to kind of model this part, we might come up with an equation of something like y equals 100 times 2 to the x. But in reality, in real life, we have this amount that is staying consistent throughout the year. And so we have this solid circle on the left and this open circle on the right. We're having this solid circle to indicate that we are including it at that month, because as soon as we hit that 1 year mark, that interest is being paid. And so as soon as that interest is paid, we jump up. And so we never actually jump up, right? So now let me rephrase that. We never actually hit 1 with the lower amount, because as soon as we hit that 1, interest is being paid. So as soon as that interest is paid, we jump up and we hold steady for a year. And then as soon as we hit year 2, right, interest is paid, and so we jump up again. So this, right, takes on the shape of steps somewhat, and so that is why we call it a step graph. Okay, and like I said, this is a type of piecewise graph, and you study piecewise graphs more, most likely in pre-calculus, and even some in integrated 3, you'll study piecewise graphs more. Now, if we did another example, instead of an exponential, we had something like y equals 100 plus 100x. Right, we'd start out the same the first little bit, but instead of jumping up to 400, we'd just continue going up by 100. And so we see that the exponential, right, in the long run, is going to be a better deal for us to invest money in. So hopefully this makes some sense on stepwise graphs and kind of how they look and why they look as they do, where they get the name, because they look like steps, and that within our model that we're talking about right now, that the solid circle is being on the left and that open circle is on the right. Hopefully this is helpful, and we'll be back in class as normal tomorrow. Have a great day.